Okay. As introduced, my name is Sang Shin, and it's my great honor and great pleasure to be here to introduce my works and then to introduce urban digital twins here in Korea. So, before start my main talk, I would like to introduce myself and my company very briefly. As introduced, my name is Sang Shin, and I'm a founder, president, and the CEO of my company named Gaia 3D. Also, I founded the OSGeo Korean chapter in 2008. Also, I'm a board member of OSGeo Korean chapter. And then, as Maria mentioned, I organized the International Post-4G in 2015 in Seoul. Also, I had served as a board of directors of OSGeo Foundation for 2 years. Currently, I am a board member of several societies, including Korea Spatial Information Society and the Korean Society of Remote Sensing. And also, I'm a board member of Korean Cartographic Association. In short, I'm a promoter of open source and open data and open standard. Also, sure. So I always try to bring a fresh air around the open source and open data and open standard to the society, academia society, and other government sectors and others. Actually, when I established my company in 2000, at the time I was a software developer. So at the time, I coded several of my personal projects in my hobby times and shared them to the public with the source code as well, like this. And at the time, actually, I don't know much about open source itself. However, that was real fun. So I coded and downloaded my programs and then also contributed to other projects as well. So during that time, I gained some popularity among community in Korean communities. And then after establishing my company, I changed my career path from a software developer to a businessman, but I still miss that time. And recently, I have contributed much to the OpenStreetMap. Actually, right side, you can see my ID end of cap. Actually, as of today, I'm ranked 6th contributed to the OpenStreetMap community in Korea. So I try nowadays. I'm no more a software developer. So every night I map the buildings and road in Korea and in UK and other places as a contribution. Also, I would like to introduce my company Gaia 3D. Actually, Gaia 3D is an open source GIS company. So we make use of many open source projects like PostGIS, GeoServer, Open Layers, Leaflet, and then the Cesium. So I established my company in 2000. It means that my company is now 24 years old now. 24 years old now. And as of today, I have 36 very talented staffs. It fluctuates although. And most of them are software programmers. So actually, I do not have any sales persons in my company. And I have 2 offices in Korea, one in Seoul and one in Daejeon. And my company's business area includes the digital twin and space satellite area and earth science and GIS software. So actually, my company is an open source software company, so we develop the software. So, and then from now on, I would like to enter into a main topic of urban digital twins here in Korea. From here, I would like to share some of the information from the perspective of government. Actually, in Korea, digital twin was first mentioned in 2017. At the time, South Korean government released a press release mentioning about that they will develop the digital twin technology. And then 2018, they included that ambitious plan to the National GIS Plan, the 6th National GIS Plan. Actually, here in Korea, Korean government makes a plan every 5 years for the national GIS. And then the 6 years ago, they included the digital twin to the 6th National GIS Master Plan. And then they showed this very, very ambitious digital twin plan. At the time, the terms of GeoCPS and then the terms of digital twins were used interchangeably. But nowadays, digital twin wins. So everybody talks about the digital twins instead of the GeoCPS. But 6 years ago, the Ministry of Land, Infrastructure, and Transport, this is the central government, they showed this kind of very ambitious vision and plan, and that they shared this to the public. So this picture includes the many core parts of the digital twin. So they try to sense what's going on there in the real world, and then they try to connect the real world and the virtual world, and then they try to feedback the simulation result or model result to the real world. Actually, this is the main concept of the urban digital twins. In 2019, central government issued a call for participation for the RFP. So here you can see the smart city pilot cities, digital twin master plan, and the pilot system development. So this is the first pilot project. Initiated by a central government, and then my company participated in this project. Actually, this is in Korean, so you may not understand, but you can see the right picture, and then at the right side, you can see the data side, GIS, 3D data, building information modeling data, and other data, and then that is called digital hub. And the bottom side, you can see the sensor layers, IoT, CCTV, drones, and robots, and other things. And the left side, you can see the visualizations and statistics and analysis and AI, securities, and other systems. By combining these three components, South Korean government tried to implement the digital twin for the citizen participations. And then over the last several years, central government invested much money in implementing the local cities digital twins. It's a sort of bottom-up approach to develop the real practical digital twins from small local cities. So central government funded much money to implement this kind of things. And then the last year, Ministry of Land and Infrastructure and the Transportation released a new NGIS, National GIS Master Plan like this. According to this master plan, they will invest 28, around 30 US dollars, 30 billion US dollars in NGIS, focusing on the digital twins over the next 5 years. Actually, this is a huge amount of money. So many people in Korea involved in geospatial technology are very excited about this ambitious plan. And another key player in urban digital twin here in Korea is the Seoul Metropolitan Government. Actually, almost all of you know that Seoul is the capital city of South Korea, and then the Seoul Metropolitan Government has really huge amount of money in their own pocket. So actually, they always try to develop their own system independently from a central government. So they try to have their own system, and they try to organize their own conference, just like Postpost Asia last year. So this is their digital twin roadmap. Seoul Metropolitan Government digital twin is called SMAP, and then you can see they started SMAP project in 2018. And then they upgraded step by step. And then after 2023, they will implement a collaborative digital twin like this. Unlike central government approach, actually central government is focusing on the uh, urban problem, but unlike central government approaches, Seoul metropolitan government is more focusing on the citizen engagement because people participation is very important to the mayor of Seoul and Seoul metropolitan government. So they always talk about how to engage the citizen participations. So they try to research to engage the citizens' activities and the smartphones and other things. So they try to regard the citizen as a human sensor as well. So Seoul metropolitan government produce and manage really many data like POI and 3D outdoor data, indoor data, and building information data. And beyond your imagination, they produced almost all the Seoul area in 3D. Another key player in urban digital twin here in Korea is the LH Corp. LH Corp is a state-owned land and the housing company. It's a very huge, big company. It's a state-owned company, and then the number of employees more than 8,000. And then they need their own digital twin for their business and jobs because their main job is developing a new town, and then providing a new land for the housing and for other development. So they started to implement their own urban digital twin from 2020. And then unlike central government, they set up their own strategy to implement LH urban digital twin. And here you can see that their strategies, and then their first strategy one is complying with international standard, OG standard and ISO standard. And they showed their strategy, second strategy is employing cutting edge technologies. And then their third strategy is they regard the digital twin platform as a sharing and collaboration platform. And very interestingly, their fourth strategy is adopting on open source. So LH Digital Twin is developed on top of open source and other things. And LH Digital Twin is developed by my company. So far, I have looked into the government side of the urban digital twins. And from now on, I would like to share my company's real experiences. So actually, the flagship product of my company is Mago 3D. This is open source based digital twin. And then here is some video, so please enjoy it. So as introduced in the video, actually Mago 3D is a web-based digital twin platform that can manage and visualize various kinds of spatial data and the simulation and the modeling result. So this is web-based, Also, it make use of a number of open source projects, including Cesium.js and PostGIS and uh, GeoServer and other things. And then this is a logical architecture of Margo 3D. Actually, Margo 3D is composed of three main parts. The first one is Margo CMS, Margo Content Management System. The second part is the Margo 3D.js. This is the expansion of the Cesium.js. It's purely open source. And the last part one is the Margo 3D Tiler. This is the Java-based open source OGC 3D tiles maker. Developed by company. So from three main core parts, two core parts are open source, but the first one, Margo CMS is not open source, and we usually provide Margo CMS as a paid one. Yeah. So recently, we opened this Margo 3D Tiler. Margo 3D Tiler is OGC 3D tiles maker. And then at the bottom left, you can see the GitHub page. And then if you visit that page, you can download all the source code, and then you can learn the Java code there. Also, the main feature and then the differentiate the feature of our Margo 3D tiler is that this is a pure open source, so there is no dependencies on any specific company or technologies. And then this is a Java-based one, so it's really portable and scalable. And then you can change the coordinate system during the conversion. Also, we make use of the parallel processing, so the tile making is very, very fast. Also, we support the extrusion. Also, we support around 27 3D formats, including 3D Studio, OBJ, FBX, and the building information modeling IFC, CityGML, IndoGML, and point cloud LAS, shape, GeoPackage, and GeoTIFF, and others. So if you have this kind of data, you can easily convert it to 3D tiles. So far, I have mentioned about the Margo 3D project. From now on, I would like to share a real project. Actually, in Antarctica, there's a Sejong Science Station. This was developed by the Korean government. And then the Sejong Station is located in the King George Island in Antarctica, and the South Korean government. And then the research institute, the KOPRI, Korea Polar Research Institute, want to manage all the facilities in a very harsh environment. So they developed this facility management with my companies. So all the two-dimensional layouts was converted to the three-dimensional beams like this. And then this is real data. And then the many scientists and engineers are living here. This is the living buildings. And then also we can sliding out the building information modeling data like this to look inside of the buildings very easily. Also, the right side, you can see the facility names. So by clicking the facilities, we quickly move to the facilities, and then we can see the what kind of facilities are there inside of the buildings and the domes and other things. And then if our scientists and the engineers are in a very harsh environment, so the managing all the machineries and managing all the facilities are very crucial for their life. So by managing their facilities and machineries using these systems, headquarters of the KOPRI, Korea Polar Research Institute, understand what's going on there. Before these systems, if there is any accident or malfunctioning in Antarctica, they usually take a photo picture with mobile phones and send that to the HQ here in Korea. And then there are lots of facilities they couldn't understand what's going on there. But if this is a power generator, if there is any more function in there, and then the user can pick that touch and then attach a picture of that symptoms and then send that to the HQ of the in Korea, and then the engineer in HQ easily understand what is the problem, and then they can help the engineers in Antarctica. So this is indoor navigation. This is just funny functions. Yeah, it's not so important things. And then this is planning support. Actually, urban planning is all about the regulations. So develop a new town is very, very difficult process. We have to go through the very difficult legal process. And as you know, every land has their land use zoning, legal land use zoning. So LH corporation have to comply with that kind of legal regulations, including floor area ratios and building coverage ratios and building height and building purpose according to the land use zoning. So to try to develop a new town here, they can put their initial plan like this, and then they adjust their plan. They can adjust the height of the buildings. Also, they can change the floor area ratio, or they can change the building coverage ratio, and then they can change whether their initial plan is met by the legal regulations very easily. And then in Korea, apartment is the common housing. It's the common housing. So we usually live in this kind of very tall building. So in this planning stages, AI, artificial intelligence, will generate the initial apartment plan considering a floor area ratio and building coverage ratio and building height and other things. And then users can change the options to meet the regulations or propose like this. So within 3 minutes, AI will generate around 20 options. 20 options, and then the users of the LH digital twin will pick up the one of them, and then they will see that option will fit their proposal or not, and then they can change slightly change this kind of planning. They will easily implement they will easily carry out their jobs. Actually, before introducing this system, apartment planning usually takes around 3 months, yeah, to comply with the legal regulations. But by introducing these digital twins, now it takes just around 3 weeks, yeah. So we reduce the time from 3 months to 3 weeks by introducing this kind of AI-based digital twins. Also, UGI, Underground Geographic Information System. Actually, UGI is very, very important and very crucial information to manage the underground infrastructures, including sewage and water pipe and gas pipe and electricity. And the problem is that we cannot see those kind of things through the ground. So, however, we have the layout, and so we can put those kind of things and combining them to the overground buildings and the other things. So now you can see the underground facilities, and by adjusting the transparency of the ground, we can see the underground facilities. Also, we can cut the profile of the underground. And then this is virtual excavation. So before starting to any kind of repair constructions, we can carry out this kind of virtual excavation to avoid the unwanted accident. Also, as I already mentioned, urban development is all about the legal regulations. So in Korea, viewpoint and skyline and viewshed is very, very important thing. So because there are lots of high buildings. So if you try to develop the new building, certain areas, and then you can put a guy here like this, and then we can analyze the viewpoint like this, and you can adjust the FOV, field of view, and then you can see what's going on there. Also, using this system, we can analyze the skyline. Skyline is also very important because the landscape itself is a kind of very important asset to the city. Also, this is a view shed analysis. If you build a building high apartment like this, and then you can see the view shed like this. We have carried out this project for the local city named Ulju. Construction safety. Construction safety is very important because construction site is prone to have an accident. So with our partners, we set up a beacon inside the apartment construction area, and then we can track the exact location of the construction workers. By doing this, in case of emergency, we can exactly locate the position of him or her, and then we can rescue him or her very quickly. And then also the same technology was also applied to the larger construction site here. So we can track the exact location of heavy construction machineries like excavators and lorries and trucks and also workers. Here now we can see the exact location of the excavators. Actually, LH Corp usually fly the drones on the construction sites regularly, and then they produce the high resolution also imagery, at the same time high resolution DSM to see the progress of the construction. And then by applying a mobile app to the construction workers' mobile phones, and then the excavators and heavy construction machineries, we can collect their movement data, and then we can visualize the heat map of the excavator movement, and then their route, how they move like this. And then if we collect and then aggregate this kind of data, this data will be big data, and then we can use this kind of big data for the optimization of the construction process. Digital twin can be used for the environment as well. Noise, yes, South Korea is very populated in a very small area, so there are lots of traffics around the road. So noise problem is very important issue here in Korea. So there is regulations. So there should be 65 decibels in daytime, and there should be 55 decibels in nighttime. So by doing noise simulations, we can determine whether we have to install a noise barrier around the apartment or not. Actually, left side, you can see the apartment side without the noise barrier. And then the right side, you can see the apartment side with the noise barrier. By installing a noise barrier, we can reduce the noise level very drastically. But we will lose some openness of the apartment side. But construction company have to comply with the noise regulations. They have to simulate this kind of things, people installing the noise barrier. Another very interesting one is that the air quality. Actually, air quality is a four-dimensional data. So this is a spatial temporal. We need a spatial temporal interpolation and visualization. So I will talk about the very static features and static phenomena. But in terms of the air and other things, it's a four-dimensional spatial temporal data. So we have to interpolate the G layers through the G layers. At the same time, we have to interpolate the time frame, time dimensions as well. So usually air quality simulation produced a huge amount of data with every 1 hour for 365 days with 7 jet layers. So we have to interpolate that, we have to visualize this kind of huge amount of data. So it was a very huge challenges, but we have successfully implemented that. So this is the case. So this animation moves very quickly, but it shows the 305 days air movement. So like this, using already observed wind data, wind speed, wind direction, and other things. Also, digital twins can be used to for the disaster management. Actually, this is the toxic gas release simulation. This is the one of the city in the industrial cities here in Korea, and in this city there are lots of chemical companies. So citizens are always worried about the toxic gas release. So Ministry of Environment here in Korea, they are trying to develop this kind of things. So this system provides two things: the scenario-based disaster management, and the second one is the reconstruction of real gas release. So now you can see here. So let's imagine that people are moving here and there just like that, and then the one chemical company accidentally released the toxic gas like this, and then the bottom side you can see the how much those was exposed to the citizens, and then and by doing this, we can estimate. So this kind of simulation is a pure collaboration between a chemical expert and my company, and then the chemical expert usually produce this kind of simulation data, and then we interpret those data and visualize that here. So this is scenario-based disaster management. But let's imagine that if the real gas release was there, and then we can reconstruct the kind of things by applying observe the temperature, humidity, wind direction, and wind speed with toxic gas materials. And by doing that, we can reconstruct the toxic gas release, and then we can provide the real assist to the citizens. Sometimes the citizens do not know whether he or she is exposed to the toxic gas. And also, we have worked with the National Disaster Management Research Institute. So this is also scenario-based disaster management. So imagine that toxic material was our truck was carrying up toxic materials, and there was a car accident just in front of the bridge. And then according to the ALOA model, it shows that the affected area of the toxic gas like this. So, and then, that village will be affected by the toxic gas, and then we should alert them to evacuate that area. Also, that toxic gas is very flammable. So South Korean government run the wildfire prediction systems. So by interfacing that data, we can overlay that here, and wildfire risk is very low, so we don't worry about that. However, because of the car accident, the car oil can be released, and then the car oil will flow down to the river, and then by doing that, okay, we have to go there, right? And then we have to block the river, and then we have to purify the river from here to there. So this is combined disaster management. Actually, this is the numerical model data from Korea Meteorological Agency. Last year, we proposed this kind of project to the KMA as a proof of concept project, and then they accepted. And then with a small amount of money, we carry out this project. Actually, weather chart is usually two-dimensional, as you see, but they have lots of layers. And then we thought that by interpolating those kind of two-dimensional weather chart, we can reconstruct volumetric data. So this is a real data from typhoon from last summer, and then we can reconstruct the wind directions and then the jet streams and other things. And we showed these results to the forecasters in Korean meteorological agencies, and the KMA is very happy with the result because this 3D technology to help forecast understand the weather more intuitively. So this year we will carry out the main project for the KMA. One other thing is the transportation. Actually, I believe Maria already have seen that here in Seoul. This is Seoul. So we've released this experimental app, so you can download here, and then you can see the real position of the Seoul metropolitan trains. So please download. Another very interesting thing is that Marvel GPT. So all of you are already aware of the power of the ChatGPT. So we try to combine ChatGPT and my company's Marvel 3D digital twin. So in front of the Marvel 3D, we put the ChatGPT. So without mouse and without keyboard, just with the text and speech, we tried to control our Marvel 3D digital twins. So here is the result of our Marvel 3D. We say that place the apartment, and then the speech to text changed our voice to the text, and then the ChatGPT understand the place the apartment, and that interface with the Marvel 3D, and then the place the apartment. And then ChatGPT placed the mixed type apartment here. We have tested AWS and Google for the speech-to-text engine, and we concluded that Google is best. And also, we have tested the ChatGPT and Llama 2 and the Alpaca, and then the Hyperclover for the large language model. And we concluded that the ChatGPT is the best. Yeah, ChatGPT really understands what we want. Yeah. And we trained the ChatGPT to understand the Margo 3D's APIs. So we have to prepare the API, MargoGPT, Margo 3D APIs very precisely, and then we trained the ChatGPT, and then ChatGPT understand the what we want, and then that take control of the Margo 3D here like this. Actually, I saw the new step. The ESRI will combine the ChatGPT or large language model to their ArcGIS Pro in coming years. So wrapping up, actually, 2 years ago, Binyu Lei, Dr. Binyu Lei in National University of Singapore published a very interesting paper, and she surveyed the digital twin, surveyed the many things from digital twin experts from all around the world. And then the right side, you can see those survey results. What are the technical challenges and non-technical challenges in implementing the digital twins? And according to the survey, the first one is the data, the second one is integration, and then the third one is the interoperability in terms of technical challenges. And then the first issue is understanding the meaning of the digital twin, and the second one is the practical value, and the third one is collaboration in terms of non-technical challenges. Actually, I was also an interviewee of this research, and I totally agree with this result because this result reflects the real life experience as well. So one of the real great headache implementing the digital twins data, I grant you that there will be no clean data. There will be no clean data for implementing the digital twins. Do not trust other people's data. Do not trust other organizations' data. They said that, oh, this is a trusty one. But when you got the data from other people, other organizations, you will realize that there are lots of dark data. Yes, and then you have to clean them. For example, in Korea, CityGML is the standard format in implementing a digital twin. Actually, we can get the CityGML data from many companies, government bodies. But when you open the CityGML data, that is not just the CityGML. The main concept, the main core concept of the CityGML is that is a semantic model. But when you open the CityGML, that is just a geometric model. Yeah. That's just geometric model. There's no words, there's no discriminations. And there's no discrimination between roofs and then walls and windows. That's just another type of 3D studio. So data is a real headache. And another standard, actually, as you are aware of that, digital twin is a digital replica of the real world. So we have to mirror the real world to the digital twin virtual reality. But there is no industry-wide standard. So industry-wide standards are currently lacking. So actually, we know there's OGC have many standards, but it's for the traditional and then the conventional just geospatial information standard. We have talked with air quality guys. We have talked with the noise guys. We have talked with other wildfire guys. There's no standard. It's really headache. So standard and interoperability are the critical for digital twins because digital twin is a system of systems, and the digital twin is a federated system. We have to agree that digital twin is not a single integrated platform. It's a federated system. It's a system of systems. By implementing this kind of very complicated system, there should be a standard or interoperabilities. So in my opinion, at least we have to standard in terms of data or interface. And then the practical value. Actually, I'm not sure I'm not sure whether my clients are here or not. Actually, I'm not sure what is the main purpose of the implementing digital twins. Actually, one of may just want to sci-fi like very photorealistic game like movie like digital twins. Yeah, but real officers want practical values. So sometimes we are at the maze. Why? What is the real value? What is the real purpose of the digital twins? So sometimes by uh, during the implementing of these kind of things, we sometimes at the maze like this. So I believe there are lots of attempts and trials and errors. And then now, in my opinion, this is just the beginning of new era, just the beginning of digital twins. There will be really broad road in front of us. So there will be still long way to go. And then but this is really interesting and really funny. Yes. So we have it's worthwhile to challenge, I believe. So this is my all my talk. So here is my company's web, YouTube, Facebook, Twitter, and GitHub. So please visit here. Okay, thank you so much for your attention. And any questions?
Thank you so much. Now I close the recording and then let us see if there are some quick questions.